Hey all, today we're doing round 3 challenge of the MEWC UK Championship 2025. This is Old Money written by Harry Watson. And I'm very pleased to announce that I received the top score of this challenge, although that had quite a lot to do with the fact that several of the top competitors such as Dim, Andrew, and Michael all sat this one out. Nevertheless, it's my very first victory of 2025, and today I'm excited to show everybody how I went about this challenge. It was very difficult. Nobody got a perfect score. Let's see if we can beat it in 30 minutes. The first level is just getting the value out of this text string. Pretty easy start. I did bring in lambda, so we can say value, custom left, -1. However, for some reason, these cells are merged. Maybe a little trap. Okay, now we're trying to split shillings and old pennies, with the caveat that not every time they're guaranteed to be there. So we have to use a little bit of error handling. So I'm going to say before S value, and if error 0. Okay, let's just give some spacing here. Double check that these all work out. See here, there's no shillings. That works. Okay. Now we'll say if there is shillings, then the logic is one way. So we want the after the space and before the D. And if there is no shilling, then we only care about before the D. So we'll say if error 0, and give me a value. Okay, get rid of here. Go away, Copilot. Now that we have the values, let's just double check. Okay, there's no pennies here, so that worked out. We can just multiply the shillings by 12 and add the pennies. And that should be good. Okay, next level is the same thing, but we introduce the pound. The pound has a symbol that I don't know how to type on my keyboard. So I'm going to make a little array here to refer to LSD and the associated values in old pennies. Should be, let's make this a little bit wider. 240, 12, and 1. Call this val. Okay, so first thing I want to do is extract the numbers. I can use regex for that. And this is a pretty simple pattern. It's just /d, one or more digits, return all matches. 4, 7, and 10. I need to convert these to values still. 4, 7, 10. Okay, good. Now we're going to split the string again using those values and the space character as delimiters. And doing so will return just the symbols that were used in this string, because they're not all guaranteed to be there. So like there's no pound on this one, for example. So I use this split text to let me know which ones I have. Then I can XLOOKUP. Actually, let's just do inline. I can XLOOKUP. Let's do this. XLOOKUP these, whoever's here, to LSD and return val. And then some product that with the digits that we found earlier. So that gives the answer in old pennies. We need to convert to new pennies. But first, I want to just save this as an intermediate lambda using OA robots. I'm going to mark input as. There we go. And then save. Actually, let's label this old money to old pennies. Save lambda. And it's smart enough to know the amount is my parameter and the took the name from the label up here. So now I can go old money to old pennies for any of these, and then convert it easily to new pennies by dividing by 240 and multiplying by 100. We need to round to 0. The reason I stuck with old pennies instead of new pennies is because I'm wary of floating point errors and conversion errors. So by sticking with the old pennies, I know that the integers are correct. Okay, so this one, we're going to go backwards. So we start off with this price list here, turn it into a table. I say we're going backwards because we're going to convert old money into old pennies and then back again. So let's call this item, and we're going to look up equals x lookup this value in items returning the 2024 price. This is the price in pounds, and multiplying by 240 gets you the old pennies. So that's OP. Now I want to take that and convert it into old money. So we're going to just say the largest value is pounds. It always goes pounds first. So we say quotient this value by 240. There's not enough pennies here to make a pound, so 0 is right. Then we'll say quotient our value minus 240 times our pounds divided by 12. And lastly, it's going to be our pennies minus pounds times 40 minus our shillings times 12, rounding to 0. Okay, so that's pounds, shillings, pennies. Now we need to add in the symbols, and the pound symbol comes before the value, so it's a little bit different than the shilling and the penny. So we're going to say equals index LSD1 and that, and then separately we'll say equals these two and drop LSD1. So we have 3 values that represent pounds, shillings, and pennies, and we wanted to filter that to exclude any of them that don't actually have a value. So that's how they're said or represented. Once we do that, we can text join with a space delimiter, and that's our old money. So this is the opposite conversion. So we've gone from old pennies to old money. So OP to OM, and mark this as my input. And now we can use OA robot to save our lambda again. So we have 2 useful conversions there. So we'll just copy this formula and then from here convert it old pennies to old money. And that should be good. Yes. Okay, deductions. Here we want to subtract one value from another in old money current notation. That's pretty tricky to do. So we convert it first, old money to old pennies. Let's make our columns bigger again. Okay, so we'll take the larger of the 2 and subtract the smaller of the 2. That's how many pennies we want. And then we just do old pennies to old money. Back again. Once you have those lambdas, it works pretty well. Okay, shopping list. So now we're going to look up the 1966 price for each of these. So it's going to be XLOOKUP, text split, semicolon, and we'll look up the item and return 1966. Okay, that's in old money format. Let's go ahead and map that lambda v from old money to old pennies, like so. Sum those up and then convert that sum back to old money again. Old pennies to old money. There we go. So that's a common pattern here, is that we start with old money. We need to do an operation to it, add them, subtract them. It's hard to do when they're in pounds, shillings, pennies. You convert it to do a single unit that you can add and subtract and multiply and whatnot, and then you can convert it back to the regular notation. Okay, level 7. This time we're going to be using these coins. I need a new table here. Let's call this TT. And so we have like quarter farthing, third farthing. The difference is that these are fractions of a penny. So I'm going to have to come out here and define these first. So I'm going to say like 1 divided by 16 plus 1 divided by 12, and on 3, 4, 6, 7, 8, 9, 10. I think I can just, at this point, I can say old, is it old penny? No, old money to old penny. Right? Yeah. That should work for the rest of these. Okay. So I've got this formula. This is old pennies. Now, like I said earlier, I'm nervous about floating notations, floating point calculations. And so I'd really like these to be integers. I'm going to just do an adjusted column called adjusted OP, where I multiply by 48 in order to get everything to be integers. So as I manipulate that, I just need to remember that I multiplied by 48. Okay, so back to our problem. We're going to create a data table and just work off of this nice clean sheet. We'll use deconcat every 2 characters. This is our codes. And then our adjusted old penny is going to be XLOOKUP of these codes to the adjusted OP. What did I do wrong? I didn't close this. And I put 2 brackets. Here we go. Okay, so that works. Now, the tricky thing is it wants to know how many items from this list could be bought with the coins that I have in hand. And so that means I need to know all the combinations of possible totals that I could add these up with. So I'm going to use the combinations lambda that takes this. I'm going to choose at least one value up to a maximum of all of them. How many columns there are there. And that gives me all the combinations. So good. You don't want those NAs. So if there's an error, I'll change them to 0. And then we'll just do a sum by row. Let's make these unique. And so this represents our possible totals. Okay, then we'll take the items that we have. And let's bring in prices. That would be 1966 price. Call that old money. Convert these to old pennies by OM to OP. And then adjusted OP is this times 48. Alright, so we have the cost of all the items in adjusted old pennies. So now I can go and say can buy. Can we buy that? And we can buy that if these values show up in our list of possible coin totals over here. So we should have a bunch of true falses. We do. From here, it's just a matter of filtering the OP. Filter the OP on all the trues. We're gonna sum those up and then convert this OP value, OP to old money, and that's our answer. Should be our answer. So put that into our data table and check our answers here. We're good. So far going pretty quick, a lot faster than I did on the original day, but we have some still difficult things in front of us. What is the total amount of money in level 1, excluding the example? Okay, so level 1 is just old pennies. We want to sum those up. Equals old pennies to old money, the sum of level 1 answers. 5 shillings is correct. Okay. Which product has seen the smallest percentage rise from 1966 and 2024? So that relates to this price table. We have old prices and new prices, but they're in different units here. So let's convert them to old pennies. So that would be old money to old pennies. This symbol is that right in this case? Let's see. Now for 2024 OP, it's already given in pounds, so just multiply by 240, and that gives us a new value. The percentage change is just that value over this, and now we should be able to solve. We'll just take the first row after sorting, sort by item, or well, no, sort item by the percentage change, and we'll take the first row. All right. In 1966, basic pay for a postie, I'm guessing that's like a mailman, was 11 pounds a week. And then by 2024, it had risen to 24,000 pounds per year. So he wants to know how much things are relatively more affordable based on the salary increase. Okay, so we're going to take this postie salary and just convert that old money notation to old pennies, and multiply by 52 to get an annualized amount. Then we have 24,125. That's in pounds. So multiply by 240, and that's the going rate in old pennies. So this divided by that gets the inflation rate. And so we're really just looking for the count of how many items have a smaller amount of change. So we can do this countif formula. There we go. All right. Some research is being done into consumer shopping habits. For each shopping list, work out how many categories are represented, average the number, and multiply by 100. Okay. So down here, level 6, we have a shopping list. We just want to look up these values. Oops, I need to split them. And return the category. Once we have the categories, let me just get a unique list by column and then count them. So I have the counts for each shopping list. Here I just want to average it. Multiply by 100 and round to 0. So 740. 740. Good. All right. The final one is the very difficult one. Find the song on the songs tab with the most money in it. So you have these songs here with lyrics, and you're meant to find the values of the coins that are referenced in the songs. So let's make a copy of the songs because I'm going to butcher this quite badly. We're going to start off, I need to know the title of each text line. So we'll say equals if this one equals that, then give me the title, otherwise give me the title from above. So this gives us all the titles, and then I want to know when does each title start with the row number. So I'm going to put equals if that equals this, then give me the row plus 1, otherwise start over at 1. And so that gives me 1 at the row of the title, which is going to help me filter right now, because I don't want to include the title, and the instructions say to omit it. So I'm going to delete these title rows, And then I'm also going to delete all the blanks and the equal signs, like so. So now I've just got title and text line, and from here I'm going to get a unique list of all the titles, and then concatenate the text for each of these using the filter. So I want to filter the text line where the title equals this unique title, and concatenate it all. Okay, now I'm going to deal in just uppercase because I'm worried about case sensitivity. And then it also says to ignore punctuation, so I'm going to strip out all the punctuation from here. So now I've got a somewhat clean title with the text that I'm meant to search. Okay, so the coins that we need to search for are here. So I'm going to take those coins and paste them in a transposed manner here. I need to convert these into uppercase. And then there's one last twist, is that it says that I need to also remember to check for the colloquial terms here in this column. Luckily there's only two, Tanner and Bob. So I need to add Tanner and Bob to this table. Tanner and Bob. And now for each line of text, we'll just count the occurrences of each of these coins and let this broadcast into a 2D table. Now we'll use Eric Gomes' famous unpivot formula in order to give us a nice that's right. Okay, A1. Here we go. Okay, so I've got this table now. Let's get rid of everything else. I don't need the text anymore. So title, coin, count, and then we can filter out the zeros. Don't need those at all. Okay, so we have a handful of coins found in each song. We want to know the value of them. There's still one more trap here, which is the fact that coin scenarios like this, where it's florin and double florin, it's actually, the current formula is counting florin even though it's part of double florin, so we need to exclude that. So I'm going to turn this into a table, call it songs, and then write an exclude column that would basically sort of florin. I'm going to say equals my value minus let's see, sum of the counts, where we filter count on is number find. We want to find our coin and all the coins, but only where the title equals the current title. Okay, and so that lets a -1 adjustment for the florin, -2 here on the crown because it found half crown, etc. Okay, so that is exclude. So our adjusted count is count plus exclude. And now we can go and value these. So I'm going to say equals XLOOKUP, the coin name in TT, returning OP. And oh yeah, if it's not found, remember I have to search for the colloquial column as well. So we're going to do that here. Oops, this is TT. Colloquial terms. Uh-oh. Bob. Did I get something wrong here? TT item. Let's try this over. Let's try this again. Don't want to panic. TT item, TT, OP. No, it's not finding Bob in our coins. Is it because of case sensitivity? I don't think so. Otherwise, the other ones would be doing the same thing. So what did we do wrong here? BOB. X lookup. Are arrays the same size? Are there good values here? Tanner and Bob, 6 and 12. Should be good. Item. Oh, I know. The lookup is the wrong. It's not. We're not looking up in item here. We're looking up in colloquial. There we go. Okay. So we multiply that by the number of occurrences, and from here we can do like a group by table. So we're going to group by songs title, and just do songs OP, sum them top to bottom. And what we want is this 317 value converted into old money. So old pennies to old money, and that should be our answer. Go. 26 minutes. That's a very good time, I think. I'm used to doing these speed runs, kind of in 15 minutes or less. This one taking 26 minutes means it's quite challenging. But a fun case. Thanks, Harry. Thanks, the other Harry, for announcing. Appreciate the shout out. See you guys next time. I'm Excel Gladiator, and my goal in creating this video is to help people level up their Excel skills, as well as grow the world of Excel esports. If you want to help me do that, please like and subscribe, drop a comment, or check out one of these other videos.